hopefully what you drew looks like this. A dot, and then approximately, now this doesn't have to be exact, 4 inches. What did I say, 4 inches? Yeah. 270 degrees is here on the unit circle. So that should have been round about what you drew. Now you didn't have to connect it like that. In fact, I didn't tell you to connect it. I like to do it just so I can see it, but technically that would be your second point. Anybody have something different they want to know why it's not that or anything? Well, fantastic. What we have just done is we have plotted a polar coordinate. Polar coordinates are different than rectangular coordinates. You're normally getting something like 3, -2, and you go 3 on the x-axis, -2 on the y-axis. But today we're going to do polar coordinates, which are given to you in this fashion. Whoa. They're given to you in r, theta. Polar coordinates are in r, theta with your radius length and your degree that you are swinging that polar coordinate. So this polar coordinate would have been 4, 270. You can give polar coordinates in either degrees or radians. This is 6.3. And then we'll be leapfrogging to 6.6, and we'll do 6.6 and 6.7 tomorrow. They're kind of snuggle buddies. This is 6.3. They go together real well. We may even enter into 6.4 today, just a brief little intro to smooth it over tomorrow. I don't think today will take too awfully long. Alright, so r theta. So the first thing we're going to do is work on plotting some of these things. We're going to work on plotting some polar coordinates. Alright, so number 1, 3, 225. That's the most basic kind. Everything's positive and it's in degrees. So you come out 3, 1, 2, 3, 225 degrees. We'll end up at what point? C. That's correct. So number 1 would be C. Now notice there's only 4 points and there's at least 9 problems, so you may have the same problem any number of times. That could happen because of coterminal angles or because of radians and all that kind of stuff. We're actually going to go to number 5 next. Number 5, 3 pi. Which one is that? That's right. Pi on the unit circle is 180 degrees, which is here. Now when you get to these, remember you have the option to convert it to degrees if you don't want to deal with radians, or you could just, use unit circle and compare them. Pi would be there, so this one would be B. We'll go to number 7 next. 3, -135. Now, if you remember, negative degrees, you could just find a coterminal. So we have the option of just adding 360. Or who can raise your hand and tell me how to find a negative degree? Anybody remember? Yeah. You could go backwards the same distance, or over the x-axis. Very good. Or you could go to the angle and flip it over the x-axis. All of those will work. Let's. I think it's easier to show what I'm doing if I do it the last way mentioned. So I'll go to 3, +135. And then for a negative angle, you flip it over the x-axis. So this would also be C. But all those would work. You could do coterminal, you could go backwards the same distance, or you could just go to the positive angle and then flip it over the x-axis. Now, negative radii. Here's what you do. You always deal with your negative radius last. Now, I'm mentioning that because if you look like here where you have negative and negative, in a minute, we're going to look at that one, but you're going to do the negative radius last. So, number 3, we're going to assume +3. So you go to +3. You're going to do your angle, 5 pi over 4, which is here. That's C. Now, last thing we have to do is the negative radius. A negative radius basically just flips you on the other side of the origin. It takes you from +3 in that direction and flips to the other side. So that would be A. That's always what you do. When you have a negative radius, go to the point as if it were a positive and flip around the origin. Number 9. So 3, positive 3 pi fourths would put us here. Remember, negative radius goes last. So first thing we're going to do is our negative angle. So if I'm here, my negative angle is going to take me to what point? Negative angle is going to take me to C. You just flip over the x-axis. From here, my negative radius is going to take me to what point? A. Very good. And that one would also be A. Positive 3 pi over 4. The negative angle flips you over the x-axis, and then the negative radius flips you around the origin. Questions about any of those? Polar coordinates? No? Alrighty. Use a polar coordinate system like shown to plot each point with the given polar coordinates. You don't have to draw a circle for every one of these. What I would do, and what I will do now, is I would just draw like one circle and just put them all on there and then just put the problem number next to it. So, like, now I'm going to do mine like it's a rectangular coordinate system just because it'll be easier to see when I draw the radius. And so forth. You guys see where I'm going. Bless you. So, number 11. 2 and 45-degree angle is going to be about right here, right? So 2, now remember, when you swing, it's like a hand on a clock. When you swing it, it's not going to be perfectly aligned over that 2 anymore. So that's the risk you run. If you overlay polar coordinates on the unit circle, then it's not going to look right. 245 is actually going to be about right here. And a lot of you are going to be thinking, but that's not lined up with the 2. You're right. But it's the 2 length swung like a hand on a clock. That's why when the book does it, they make like those circular so that it's easier for you to see, where you're going to be. But when you're drawing it, that's going to be kind of hard to duplicate. So just remember, when you swing a polar coordinate, it will not line up perfectly with the length of the radius. Oh, ho-hum. Let's look at 17 and 19. 17. You come out 1 unit. You swing all the way around to pi degrees, which will put you right here. And then, what's the negative degree going to do? It's going to flip you over the x-axis. Well, what happens if you're on the x-axis? Yeah, that's not going to take anywhere. So it's just going to end up staying right here. Oh, I'm sorry. I was thinking negative angle, not radius. My bad. Negative radius flips you around the origin, which takes you right back to where you started and here. So this would be number 11. This would be number 17. Oops, I was thinking negative angle. My apologies. Questions about that one? What about 19? I'm not going to draw it yet. You visualize where you think 19 is going to be, and then we'll take a look. Try to think about it. There we go. Let's see if your visualizations are correct. Positive 2, positive pi over 2 would take us here. Now, the negative angle comes first. Flipping over the x-axis is going to take me where? Straight down. That's right. When you are right along the y-axis, that's where a negative angle and a negative radius are going to kind of do the same thing. Because flipping over the origin and the x-axis are like the same thing on this one point. So, the negative angle takes us down here. And where's the negative radius going to take us? Exactly where we were. So, there's number 19. And that's how I would personally do this section of problems. That way you don't have to draw a whole bunch. Questions about this? Is there another example somebody wants to see from this page? Okay. Alright, use a polar coordinate system like the one shown to plot each point with the given polar coordinates. Then find another representation of this point. Okay, that just means, if you remember back from our first slide, remember how there were multiple with multiple answers? Like 1 and 7 were C, 3 and 9 were A. What caused those to be the same? Well, this just had coterminal angles. That's probably the easiest way to come up with a duplicate point, is just find a coterminal angle at that point. But these were made, well actually these are also coterminal, so that's how they did those. What's another way you could come up with the same point without just using coterminal angles? Really, there's only one other way to do it. Without just changing the angle, what is another way we can come up with the same point? Well, what's that? Yeah, changing the sign on the radius. Let's see, these two were both point A. Well, let's see. And they were both -3. So what's an angle for this, and make it as basic as you want it, that you could get for A with a +3? How about +3, 45 degrees? Bang, there's another representation. You just changed the sign on the radius and simplified the angle. There's infinitely many ways to make all these angles. So let's look at some of those. So number 21, they say plot each one. We already did that, so I don't really care if you plot these, but I do want you to do the next three parts. You have to find 3 coterminal. That's not entirely true. You have to find 3 other representations for this polar coordinate meeting these criteria. 21, radius is positive. Well, here's the thing to remember about these. Your radius isn't going to change. So, all you really need to know if it's positive or negative. So this one's positive. Okay. Well, if the radius is the exact same, then what do I need to do to find this angle between this range? Yeah, just add 2 pi. Find a coterminal angle with that one. What's pi over 6 plus 2 pi? 13 pi over 6. And this actually, in this point, turns just like what that last section was. Next one. It says negative radius. Uh-oh. Now, let's stop right here. If we know our radius is negative, so we know that we need to end up, before we flip around the origin, you're going to need to end up on the exact opposite side of the unit circle as pi over 6. Look at your unit circle. What value is exactly opposite of pi over 6? It should also be if you could just add 1 pi, so you could send it. What is directly opposite of pi over 6? 7 pi over 6. You can get that from looking at the unit circle. You can just add 1 pi, or if it's greater than that, you subtract 1 pi. Boom. And there is part B. Negative radius, and our angles between 0 and 2 pi. Check. Part C, which I will do down here. Positive radius. So we're just finding a coterminal angle again. But instead of adding 2 pi, they ask us to do what? Yeah, subtract. We're in a lower range now. So we subtract 2 pi from that, and what do you get? Very good. Negative 11 pi over 6. Boom. There's A, B, and C. Try 23 on your own. Try to find A, B, and C on 23 on your own. Let's see what we get. If you don't have your answers, let's just, out to the side here, and you need to write this somewhere in your notes so it'll be easier later for you. Let's just write out a little trick to what A, B, and C are actually asking you to do. A, same radius, Add 2 pi to the angle. That's all you had to do for part A. Part C, same radius. Subtract 2 pi from your angle. So A and C were literally, that straightforward. And part B was opposite radius, opposite angle on the unit circle. You literally go directly opposite of wherever you were in the unit circle. There you go. So, that in mind, what did somebody get for part A for number 23? What did anybody get for part A in number 23? Okay, same radius, add 2 pi, and you get 11 pi over 4. Remember to make your common denominator. Part B, opposite radius. What is directly opposite of 3 pi over 4 in the unit circle? Thank you, Alyssa. 7 pi over 4. Believe it or not, I don't like hearing myself say all the answers. Same radius, subtract 2 pi from 3 pi over 4, and you get, oh, beautiful sound of students. Very good. Questions? Okay. That should be positive. Oh no. Alright, go on. What? Look at your unit circle. Whatever angle is directly opposite of 3 pi over 4, like take this, make a straight line to the origin, and keep going to the other side. There you go. Yes, ma'am. Oh. It is. Negative 5 pi over 4. Select the representations that do not change the location of the given point. Now these, I personally think it's easier to draw. You don't have to, but if you draw them, then you could just see them firsthand. Okay, so 7 140 is 7 140 here. Now notice, all the radiuses are the same absolute value length. So it doesn't matter if it's the scale. Really all you're checking here are the angles and the sign of your radius. Part A, negative 7 320. Well, positive 7 320 would put you here. And then with a negative radius, that would flip you over the origin to here. So A, select the representation that do not change the points. A did not change it. So A is one of our answers. B, negative 7, negative 40. Well, positive 7, positive 40 would put us here. Negative 40 would put us here. And then negative radius would put us here. So B also did not change anything. Part C, 7 220 would take us here. Negative radius would take us here. And that's all there was to do. That one changed it. So C is out. Part D, positive 7, negative 220. Positive 7, positive 220. And a negative radius, or excuse me, negative angle does what? That's right. It flips us over the x-axis. Yikes. So D is also a representation of the original point. Well, I can either interpret your absolute dead silence as this is easy and I could just keep going, or as questions. Raise your hand if you'd like to see number 29. Okay, see hands. That's good. Signs of life. Here we go. 2 negative 3 pi over 4. So 2 positive 3 pi over 4, if you look at the unit circle, would be here. Oh, but I forgot to make the angle negative. The negative 3 pi over 4 is going to flip us over the x-axis and make it here. So there's our original point. All right, part A. 2 negative 7 pi over 4. 2, where's positive 7 pi over 4? Which quadrant? Fourth quadrant. And then the negative angle is going to flip it to which quadrant? The first. Is that the same as the original point? No, not that one. Part B, 2. And which quadrant is 5 pi over 4 in? Hey, that's the same point. B is one of them. Negative 2, negative pi over 4. So let's go to positive 2, positive pi over 4. Now we're going to do our negative angle. Flips us over the x-axis. Then our negative radius flips us into which quadrant? The second. Is that the same as the original? No. So you can cross off C. Part D, negative 2, negative 7 pi over 4. So positive 2, positive 7 pi over 4 puts us here. Negative angle flips us here. And the negative radius brings us home. So BD. Questions on that? Yes, sir. Let's see. Let's say we had done that here. Let's see. So positive 2, positive, negative radius, negative angle. Maybe it won't. I can't think offhand of ones. I want to say there was a reason in the past I had a class that we just decided to always do the radius last. I don't remember why that was. It may not ever. But if you ever find a time where if you get feeling curious and you want to do it both ways, and you find where it makes it different, let me know, and I can answer that question from somebody else better in the future. But I don't guess I know of a time where it would. Other questions? Okay. You're going to need the 2 highlighted formulas shown there. We're going to be taking polar coordinates and converting them to rectangular coordinates and vice versa. So like I'll say 4, 3 pi over 2, and I'll be saying, where would that be in a rectangular coordinate system? And you'll need those formulas. Or I might say, here's a point, 3 comma 6, convert that to polar coordinates, in which case there is no formula. Well, it's not entirely true. But we're going to use logic for those. But the 2 highlighted formulas are going to get you from from polar to rectangular. And put a star or smiley face or animated penguin or something in your notes next to those 2 little formulas, because every time we do a quiz or test over this, people are like, oh, I don't remember how to do that. You need to put something next to this with big, bold letters saying converts polar to rectangular coordinates. Or however you want. But those are the formulas to convert from polar to rectangular, not the other way around. Because you have to know r and theta, and then they'll give you x and y. Now, the solution, if you want to see why that's the case, it's a very simple little trigonometric thing. You know, if you have theta, cosine of theta is x over r. So if we're solving for x, we just multiply the r to the other side. They're very simple little geometric things. We're not even going to take time to look at them. But here we go. Polar coordinates are given. Convert them to rectangular. They're literally this simple. Shall we head up? The x is going to be 4 cosine 90. And the y is going to be 4 sine 90. One hint. Do you think we need to be in degree or radian mode? Degree mode. On number 37, what do you think we'll need to be in? Radian. You're going to have to bounce back and forth. Yeah. Somebody punch him in. Let me know what you get. Should be 40. Oh wait, no, you are completely right, sir. 0, 4. This one gives you 0. This one gives you 4. Therefore, your coordinate is 0, 4. Thank you. You were correct. I was incorrect. 37. Same thing. Just make sure you're in radian mode. Negative 4 cosine pi over 2 for your x. Negative 4 sine pi over 2 for your y. What doth that give you when you punch it in? Gesundheit. Are you in radian mode? Nope. You know I asked you that because you need to be in radian mode. Okay. What was it? Thank you. You're like, no, I'm not. Like, okay. That's funny. Okay. 39. Is that in radians or degrees? Radians. Just because there's no pi doesn't mean it's not radians. If there's a little circle up there, it's degree. If there's not, it's radians. So even though it doesn't look as pretty, and you're probably going to get an ugly answer, this would be 7.4 cosine 2.5 in radian mode, and 7.4 sine 2.5. X, Y. Well, might have to boot up my calculator. You know, it doesn't say. So round it however the dang heck you want to. .4. Excellent. Questions on that? Did anybody get something different than that they'd like to take a look at? Okay. On a test, it'll be multiple choice, so it'll be obvious how they want you to win. Okay. Excellent. What about going the other direction? What about taking a rectangular coordinate and converting it to a polar coordinate? Well, this one's a little simpler. Well, I say that. Technically, those last ones are more simple. But these you can do using trigonometric logic, which I love doing. So, 41. Negative 2, positive 2 takes us here. If I were to connect that, making my reference angle, negative 2, positive 2. I need to find r and theta. How am I going to find r? Pythagorean theorem, a squared plus b squared. What is that, square root of 8? 2 radical 2. And how am I going to find theta? Wow, that was even more advanced of an answer than I was expecting. I was thinking somebody was going to say, SOHCAHTOA. I'd say, which trig function? You'd say, opposite and adjacent. That must be tangent. But you just jumped straight to the gun, didn't you? Tangent of theta equals opposite over adjacent. Now, I'm going to pause for 2 seconds, go back to this slide. That's what this was telling you. How to go in the other direction. You're going to use Pythagorean theorem to find your r, and you're going to use this to find your theta. Now, if you don't want to draw these, I just kind of like to look and think about it. But that's essentially what you're going to do with y and x every single time. So if you're the kind of person that's like, I don't want to draw, I'd rather just punch it into a formula, and that's fine. I'm not criticizing. Then write those down, and that's how you take from that's how you take from rectangular to polar. You just plug x and y into those two formulas and solve up. Of course, they should have just said tan inverse of y over x, and that would have been easy. Because that's essentially what you're going to have to do every single time. Now, when I am told to take something and put it into polar, I always just prefer to do it degrees. You don't have to, but I think it's prettier in degrees. So that's how I'm going to do it. So, what was tangent inverse of negative 1 in degree mode? Negative 45. And that would work. You can just leave it like that. So that would be 2 radical 2, comma, negative 45. Why would I do an... Oh, because we got tan of theta equals 2 over negative 2. Yeah. Now, as I look at this, let's think about the why. Remember how law of sines, we had that one situation where it would give you the wrong answer because it had 2 possible solutions and it always gives you this one. Tan inverse is kind of going to have the same deals. If we were to graph that coordinate, where would it put us? 2 radical 2, 45, negative 45. Is this the correct answer? Is this where our original point was? No. That's what the answer I was going for was no. No, this is not the same as up there. What is the only thing I would have to do to this to make it go up there? What have we been doing all day that flips us around the origin? Yeah. When you do these, it's a good... This is why I always just use logic in the past so that you can visualize it. You've done it correctly, but tangent has the same flaws as any other trig function. It may give you the correct quadrant or the wrong quadrant. So, what you're going to have to do is actually look at your answers and figure out, did it give me the right answer or did it give me the opposite answer? Now, because negative tangent is going to happen in these 2 quadrants and positive tangent is going to happen in these 2, it'll either have given you the correct answer, smiles, because you don't have to do anything, or it will give you the directly opposite one. And if that's the case, you'll just need to change the sign on your radius. Bang, now it's correct. You will have to do a little thinking on this section. You're going to have to look at it and say, is that right or is it wrong? If it's right, you're done. If it's wrong, change the sign on your radius, and it should be right. Let's look at a measure. How about 43? 43. Let's see, positive x, negative y. That'll put us here-ish. I'm just sketching. It doesn't have to be to scale. 2, and then this side is negative 2 radical 3. I'm seeing a lot of people when you square, when you square radicals, I'm seeing a lot of people make the same mistake, and that mistake is you're squaring the 2, which is good, which should be 4, but then you're also squaring the 3 and getting like times 9. No. When you square a square root, what happens? You just take it away. So that's the same as 4 times 3. Now, so I say all that so we can start solving for the radius. A squared plus b squared equals r squared. This is going to be 4. This is going to be 12. Therefore, my r is going to be the square root of 16, which is 4. So it's going to be 4, comma, something, and we may have to change the sign on that. Okay, so just like what we just looked at, tan of theta for all of these is just going to be y over x. Yes, you could just cancel the negatives. Somebody punch in tan inverse of that fraction. Feel free to not use the negatives. Yeah, that looks about right. Negative 60 degrees. Now, quick, let's look at that. 4, negative 60. Is that the right place? Yes, so we don't have to do anything. You gave us the correct one. Tangent, you know how sine always gave you first quadrant? Well, cosine will always give you one of these 2 quadrants, and tangent will always give you one of these 2. So, if your original point was in the first or fourth quadrant, it's going to give you the right answer immediately. But if your point's in the second or third quadrant, that's when you're going to have to change the sign. So just kind of a rule of thumb. All right. Questions on how we're doing that or anything from that slide? You mean of the trig functions? Oh, I said when you do this to find your angle, it'll always give you either positive 0 to 90 or negative 0 to 90. So it'll always give you something in the first or fourth quadrant. So if your point's in the first or fourth quadrant originally, like this one was, it's going to give you the exact right answer. But if it's like this one and it's in the second or third quadrant, it's going to give you the exact opposite of your answer, and you have to change your radius. So first and fourth is smiles, second and third is a negative radius. And yes, my voice cracked. Okay. Questions from that? Say that one more time. Oh, yes it is. Spam.